Hello, Chandru again.
Hi, how are you?
Fine.
So can you see my video or just the icon?
I can see your image.
Oh, just my image or my moving around?
Yeah. Oh, yeah. You're moving around.
Okay, good. Just making
Yeah,
sure.
you're live. This
Yeah.
looks like a normal Zoom to me.
Well, I have two sessions. That's why I wanted to know. All right. So were you able to get a Google account?
No, I went and looked. I looked at my Google account, and it definitely is that number, that address.
So we'll have to
Scott Dixon.
try something over Zoom to see maybe there's something.
Yeah, I think so, because when I go to that link that you sent me in an email to the Hotmail address, which is kind of how I managed to get on this Zoom. It thinks I'm the instructor or a instructor. It doesn't seem to treat me as a student.
Yeah.
Believe me, I don't think I can instruct the course.
Yeah, no problem.
So maybe we need we don't want to waste everybody's time on that, but maybe we need a Zoom, separate Zoom.
Yeah, we can try that sometime next week. Probably not today.
Yeah, that's fine. I'm jammed too. So you're up in Seattle?
Yeah,
Whereabouts?
in Wallingford.
Wallingford.
Yeah, and where are you? Where are you?
And San Diego.
San Diego. Yeah, I'm in Seattle proper. It's just the Wallingford is just a neighborhood in Seattle.
Uh-huh. Yeah, I used to live up there in the 60s.
Ah, I see.
That was some time ago.
So this is just right on Lake Union.
Uh-huh. Right, got it. On the North Shore, is that?
Yeah, by Gasworks Park.
Yeah, I know where that is.
Mm-hmm.
Hi, Scott.
Hi, Anna. How are you?
I'm
Haven't
doing,
seen you in a while.
I know. I was a little MIA for a little bit, but I've been here gardening.
Good.
Yeah. Been trying to grow my green thumb.
Good idea.
Yeah, I needed some of that right now with everything going on in the world. So
Yeah, for sure.
Hi, Anna. This is Chandru. Nice to meet you.
nice to meet you, Chandru. Thank you for having these classes available to us.
Oh, sure, absolutely, no problem.
I took a Python class a few semesters back, and I was like, well, not sure what to do with this. I want to use it, don't know how to use it really. And next thing you know,
Yeah, this Python is going to be very, very basic. It's not going to be very advanced at all, but just enough to be dangerous. So
better than nothing, because that class didn't touch on anything with astronomy. So this is something.
Yeah, what I'd like to understand is some of the tools and libraries that you can get to that are useful in the sort of things we do.
Yep.
Hello.
Hello, everybody.
Hello.
Welcome. See Joseph, Alan, Belny, Joe, Eva. Hello, how are you, Eva?
Hi, I'm doing well. How are you?
I'm fine, thank you. Let's see. Got Kyra. Am I pronouncing that correctly?
Hi, it's Kira.
Kira, okay. And Philip, Doug, Lancy. Welcome. All right. So I think, let me see. Let's just give a couple more moments. There's Lena. Welcome to all. So I wanted to get a sense for where everybody is joining from. I'm here in Seattle, Washington. I think most of us are from the United States, but I do think there are people who are going to join us from India. So as we are coming in, I don't know if you're all familiar with Zoom. Most probably you are. But I just want to get some reactions from all of you. I just want to ask a couple of questions just so I can get a little bit more familiar. So if you are a student of high school, or you're a student in college, can you do me a favor? Go to your reactions and give me a thumbs up if you're a student. All right. So looks like 4, 6, 10, 11 students so far. Thank you. Appreciate that. And then second question, if you are joining from the United States, can you give me a thumbs up? All right. Looks like all of you are from here. Doug. Okay, so Doug is from the US as well. So I guess I have not got my international students yet. So hopefully they'll be joining. Now, we are in Pacific Daylight Time. And I know for the Indian students, it will be 12 and a half hours, I think, ahead of our time. So see if they join. But how is everybody today? How's everybody doing? And you can unmute yourselves if you'd like.
I'm doing
Good
good, thanks.
evening.
It was here in San Diego, it was over 80 degrees and sunny all day. So
Yeah,
we sure can't complain.
yeah, the weather has
Mike
been
from
New Mexico, right? Mike, hi, Mike.
Yeah, it snowed here today.
Oh, really? No kidding. So
Yeah,
I have another
just got back
question.
yesterday from a beach.
Oh, cool. I have another question for all of you, so I can get to understand the demographics a little bit. So how many of you are amateur astronomers? By that, I mean you watch the sky at least twice a year, sky gaze twice a year.
And nobody pays us to do it.
So like 5, 6 of us, yeah. Mike, who has just joined us, just built a outdoor observatory in his backyard. Yeah, all right. So good. So thank you all for joining. We'll get started. Renisha is coming in. So that's one of the students here from India. Hello, Pat.
Hi, sorry, I got distracted with how to log in.
Oh, no, that's quite all right.
That's okay. I got,
Renisha, welcome. So can you hear me all right?
yeah,
I just want to make sure that I'm able to hear Renisha. She's joining from India, so just wanted to check that.
I think Rindisha is joining from Georgia.
Oh, she's joining from Georgia. Okay, okay, all right. So then I guess we don't have any international participants. I made the wrong assumption on my part.
Okay.
All right, very good. And so for those of you who are able to turn on the video, please go ahead and do that. It helps me to see everybody's faces. And sometimes we gesture, say yes and no with our face, and I don't know who's saying what. Okay, all right. Well, thank you very much for joining. So Pat asked me if I would be able to run this 5-week seminar. It's actually going to be 6 weeks, but we will have 5 sessions that primarily focuses on not necessarily teaching astronomy per se, but using 1 or 2 concepts or 1 or 2 things about astronomy and use that topic to teach how we might use Python to query astronomical databases and simple ways to use Python in an embedded fashion inside of Google Colab. So another poll, sorry to do all these polls, but I just want to get a sense for where everybody is. So how many of you have used Google Colab before? All right, so Google Colab is new to most of you, it looks like. So that's fine. This is supposed to be a beginner class, and I'm not an expert in anything. So Google Colab, astronomy, mathematics. I'm not an expert in anything, so I'm going to be learning a lot of things along with you. By the way, my background is I am a computer science teacher and mathematics teacher at Bush School, a private school here in Seattle. And I'm also an amateur astronomer. I've been looking at the sky ever since I was a child back in India, and that interest continued. And so now I actually have a telescope. I have a reflector telescope, an 8-inch Newtonian telescope that I use. And we also purchased a telescope at the Bush School. So I'm going to be teaching astronomy starting next semester at the Bush School. This is a high school. And So we have a telescope at the Bush School as well. So yeah, so that's a little bit about me. And I'm glad to have this opportunity to talk to all of you and introduce you to Google Colab and how to use Google Colab to query data from satellites and whatnot. Okay, so let us start with, I'm going to share my screen now. Okay, I'm going to share my entire desktop because we're going to be going back and forth between multiple screens, and it might be easier to do that. So are you able to see my desktop all right?
Yes,
Yep.
Is the lettering too small? Are you able to see these letters? See the screen with the writing on it? All right, so if you are talking, you may want to mute yourself. So, okay, that's good. All right, so this is the Python for Astronomy course. We're starting the first session today. The astronomy textbook that I'm going to use, and this is a really good textbook. It is provided by OpenStax, and all of these links are available in a convenient place as well. But I just wanted to introduce that. So a lot of the slides I'm using here will come from this textbook. And what I like about this particular textbook, and I'm just going to open it here. What I really like about this textbook is that it is available for anybody who wants to use it. It is, if you want to print a copy, it costs money. Otherwise, it's free. And you can view this online, and it is being updated. It's got 20 chapters. It covers the solar system. It covers the universe at large, and it is constantly updated. But what I really like about this book is that it has a lot of exercises that you can do. So if you go to a chapter here, let's bring up. Let's see. Let's go to. Okay, Renisha is joining again. If you go to a chapter, and at the end of each chapter, you will find that there are exercises that you can do. A lot of this actually is the background mathematics that you're going to need to compute, distances to heavenly objects, or data. Where can you go to get data from different satellites and so on. So we're going to be looking at this textbook throughout as we go through our sessions here. Okay, so the next thing I want to do is to let you know about the Python online reference. There is a book. This is, again, that's freely available to any of you, and so this is a good reference to learn a little bit more about Python. We're going to cover really just the basics. Okay. And then I've created a helpful links document here, and we will go through all of that. But the first thing I really want to do is to go through the Google Classroom. I suspect that all of you have successfully joined this classroom, and you're able to see this main page. Is that correct? Can you let me know in your in the reaction so that I get a sense for if anybody is having trouble. If you are having trouble accessing this Google Classroom, we need to fix it immediately, because a lot of what we do here is using Google Colab, and I'll be providing links for you to use via the classroom. And How many of you have used a Google Classroom before? I just want to know to what extent I should really cover the basics of Google Classroom. And it looks like most of you have. I'll just briefly talk about these menus here. The stream is where when, let me put this away. Not that. The participants window, there we go. All right, so the stream is where when I'm posting something new, it shows up here. It'll show up in chronological order. So my first posting was back on the 13th of March, and then these are more recent postings that you see. The other thing I wanted to tell you is that each week there is a different Zoom session. It is not the same Zoom session because I've had trouble with unsolicited visitors. And so this way it is protected. And so don't rely on the Zoom link being the same. Each week it is different. So to join a session, simply click on the week, and then in here, you'll have all the information. This way, nobody needs to exchange any passwords or anything by email. Okay, the other thing I wanted to let you know is that the very first day I assigned a entry ticket quiz. I think most of you have taken it. And so I got responses from most of you. And the idea of that quiz was to really make sure that you can access the Google Classroom for the most part. But a lot of you coming in have already taken Pat's Intro Stars course. Is that correct, Pat?
Yes, I think everyone here has taken either that or an associated course with Rachel Freed.
Excellent. So it is not that I'm going to depend on your knowledge from the Intro Stars course, but it will be helpful if you have already taken that. But I will be talking from a very basic standpoint, so I don't think you'll be lost at all in this class. Next, if you go to classwork, this is where all of the reference materials are posted. And for each session, if there are special things in addition to the Zoom, I'll put it there, and other materials will show up here. So if you were to click on the reference materials, you can see the link to the astronomy textbook, and you can see the link to this session outline that is here. So you can also access the session outline or any other references by using the Google Drive that is associated with your Google account. So if you were to click this and go to Google Drive in your account, it might look something like this. In fact, let me do that with my student account. So it'll be a little bit closer to what you're looking at. So this is my student account. So you might see here, if I were to go to the Google Drive, you will see these files have been shared with you. And so here is a Kepler activity that we can do. Here is the helpful links, Colab file, and other things. And so they will show up in the My Drive, or they'll show up in the Shared with Me folder. This is where the Shared with Me folder, by the way, in Google Classroom, and this is an important concept, is when I share things with all of you as students, it'll show up in this Shared with Me folder. Then, if you want to make a local copy of something on your own My Drive, then what you have to do is, for instance, if you want to make a local copy of this astronomy textbook, you can right-click on it and then say, make a copy. If you do that, it's going to make a copy and put it into the My Drive folder. And so whatever you see here, not these suggested, but whatever shows up here, these files are ones that are owned by you. So your name will show up. But if you go to shared with me, you see these files are not owned by you. They're owned by me or owned by Voice Astro. So you won't be able to edit these files. Whereas anything here is fair game to any of you. And I will ask you to be copying those files to your My Drive, some of them, to make some changes to. And you see, this is simply saying, that it is a Google slide, but you see this sort of infinity symbol. Actually, it's a CO symbol that stands for Colab. So it is a special file for Colab, and we're going to be creating some today. All right, so let me just stop there for a moment. Are there any questions or comments before I continue further? I just don't want to be talking all the time and not knowing, not giving you a chance to speak up.
I do have one quick question for you.
Uh-huh.
So I clicked on the drive links for Python, Colab, and GitHub, and I only have one file. I just want to make sure that I have the correct access to it.
Okay, so you went to this Google Drive from your login, is that correct?
Correct.
Who's talking, by the way?
Joseph.
Oh, Joseph, great. So Joseph, underneath this, these suggested things can be very confusing, but if you go to shared with me, these are all, well, you won't see this many, but you will see some of the files that I've shared with you. You should probably see the P4 session outline. You should probably see the astronomy textbook. You should probably see this Kepler activity. Do you not see
Okay,
those three
I
files,
do.
Joseph?
I do. It just wasn't showing up in the specific Colab folder itself, but in
No, it
shared
won't show up
does.
there because Colab folder will only contain any Colab files that you create or that I share with you.
Okay, thank you.
Because this one is a Colab file, whereas that's a Google slide, that's a PDF. Okay, good question. Any other questions?
You answered my question.
Hi, Chandru.
Yeah.
Yeah, hi, this is Ram.
Hi, Ram.
So
How are
I
you?
was the one who joined as Renisha initially.
Okay.
For some reason, I'm using her laptop.
Okay,
So,
no problem.
yeah. So the thing is like, this shared with me, I can only access it from my Google Drive, right? Not from the classroom.
From the classroom also, you can access it. So you can basically go to the classroom. And then if you go to the references, and you can click on the session outline, which will basically give you this presentation. And then from here, there are links that you can use. It'll take you back to wherever these things are. And some of them are in the Google Drive.
Okay.
So you can do it both ways. But I think if you're using the classroom, it may be easier because it'll take you directly to where you need to go. All right.
Okay.
Good.
So that one more thing. What's the difference between the, Colab and, something else in Google Cloud?
Yeah, so Colab is an application in the Google environment. And that application will allow you to create dynamic digital documents that it's like a website. It's like a mini website that you can create. But the beauty of that is you can write code inside the Colab. And so we're going to do that today. You'll learn a lot more about that today.
Okay.
All right.
Okay, thank you.
Excellent questions. All right. So let's go back to our walkthrough of the Google Classroom. People is where you'll see all the participants, and then this is where I get to know who's joined, and if you're working on exercises. You can always ask me questions here. You can just provide a comment, and if it's a question that you think everybody will benefit from, you can ask it here. The other way for us all to communicate is Slack. So let me open up Slack. Now, the Slack link was also posted here. So for instance, you can get to the Slack link by clicking on this. If you're not already on Slack, we might choose to exchange information on Slack also. So let me know if you have access to this particular channel in Slack called Python Intro. All right. So sorry about this long introduction. We've already taken about 25 minutes, but we'll get going here. So the course goals then are, we're going to learn about Hertzsprung-Russell diagrams, which is a way to look at conglomerations of heavenly objects. You know, it could be all the stars in a galaxy, or it could be stars in the Hercules globular cluster. And you may be able to look at this diagram and tell some information about, you know, what is the sort of characteristic of the cluster as a whole when you compare it to the ages of stars in your galaxy, as an example. There are lots of things you can learn from that. So we're going to learn about the Hertzsprung-Russell diagram, but along the way, we are going to use that topic to learn about Python for astronomy. So you're not going to be experts in anything at the end of this, but you will get to learn enough to play around with it. So we will learn how to use simple queries using Python and doing it in an embedded fashion in Google Colab. We will be querying satellite databases, you know, from the Kepler mission, the Gaia mission, and using that data to plot information that we get. And our end goal is to create HRDs, Hertzsprung-Russell diagrams, for specific star clusters and determine their age based on what the diagram looks like. So those are the course goals. By doing that, we're going to learn a little bit about each of these topics. Are there any questions about the goals of this class? Okay, so logistics wise, I talked about the Google Classroom. There'll be 5 sessions every Thursday starting at 8 o'clock for an hour. And I can, you know, we can extend it a little bit longer if you're able to stay a little bit longer. I mean, if you want to, if you have questions and we're working on things together. I hope for all of these to be a lot more hands-on than the very first session is today. We'll start to do some things almost immediately now. So, all right. So our first goal really is to set up Colab for this session, and then we will embed some images and videos, and we can do some astronomical calculations. So that is what I've set up as a goal for ourselves today. All right. Okay. So I think we talked about all of this. Oh, recordings are being made, by the way, for each session. And those recordings will be available to you after we can process them and put it out on the Voice Astro website. Yeah, that's about it. Are there any questions that I can answer?
So you're gonna do all this in Collaboratory, right? And my experience
is using Colab, and some point we'll start to use GitHub and other applications as we need it.
Right. My experiences with the Anaconda environment for Python, and I suppose that's not going to be addressed at all in here, right?
No, we're not
just
going to
take that off the
Anaconda
table.
environment, but I can answer questions at some point if you're interested.
Yeah, fine.
Okay. Any other questions? It looks like Robert had a question. Robert, your hand is up. We can't hear you. All right, so we'll keep going.
Yeah, he's muted. Oh, there he's unmuted.
You hear me now?
Yeah.
Oh, okay. I was wondering where you have the invitation for the Slack channel.
Oh, for the Slack channel,
Yeah.
if you go to the references, actually, if you go to the presentation that I've been following here, I've got a link right here,
Okay.
and you can click that. And Pat, maybe you can add Robert Baker to the Slack channel. All right. So let's
you.
start by doing stuff. Enough with the logistics. So this slide just shows you some of the observatories that create data that we can actually access. And so some of these links here will lead you to those observatories. We're going to look at some Kepler data and Gaia data for the most part for doing our work. So I want to start by simply introducing the idea of what happens to starlight as it spreads and reaches Earth. So brightness decreases in proportion to the square of the radius. And the reason for that is, if you know a little bit of the way that light propagates, it propagates in a spherical, in a spherical surface, and the radius of the radius of the sphere is the direction in which the light is moving. And so, if the light has, let's say, traveled 1 unit, let's say that's 1 light year, then the area that you see here, this little square, is increasing, is proportional. It's proportional to the square of the radius, and that's because the surface area of a sphere is given by the formula 4 pi r squared. So that's the surface area of any sphere. Therefore, what happens is that the light gets spread out along this square. And then if you go 2 units of distance, it gets spread out further. Right now, you got 2, and since it propagates to the square of the radius, now you've got light diluted. What used to be all in this 1 square now is in 4 squares, because 2 to the power of 2 is 4, right? Then 3 to the power of 2 is 9. So now if it is 3 light years away, you see that as light travels, it gets diluted more and more and more. So just to ask a question, can you do this kind of calculation in Colab, just so we get a sense for how this works by using embedded Python? It's very simple. You don't need embedded Python to calculate it, but it'll help us figure out how to do this. And that's the first exercise that we're going to do. And so we've sort of talked about the formula, and this is what I want you to do now on your systems. So go to your Google Drive and basically select the applications here. And when you do that, you will see this particular, let me make this bigger so you can see it. You will see this P4A, which stands for Python for astronomy, Kepler activity IPYNB. That's the file that I've shared with you, okay? So what I want you to do is right click on that, just like it is shown here. And then basically, right click on that and then click this make a copy button, right? Like this, right? When you make a copy, it's going to put it into your My Drive folder. So I'm going to do that from my student account so you can see what I'm talking about. So I went to the shared with me folder and I right clicked on the P4A on this file, P4A Kepler activity. And then I'm going to make a copy just like that. Click make a copy. And once you make a copy, you'll see this show file location. It's actually gone into this My Drive. So now you've made a local copy. And then there you will see here this copy of P4A Kepler activity IPYNB. And what that stands for is Python notebook. That's what that stands for. So do you all see this file? Are there any questions? Robert, do you have a question? Okay, looks like some of you are able to see it. So if you can see it, just go ahead and double click on that. This file is owned by you, right? So if you double click on that, you should see this digital document that has pictures and that has formulas. It has other things in it. So my question to you all is, have you made a copy of this file and you're able to see this digital document? Do you see this? Or do you see something like this? Because it doesn't know how to apply that file to Colab. If you see something like this, then what you have to do here is, I'm going to make this bigger, is you'll have to go to the top middle of this window and then select Open with Google Colab. That's the thing you have to do. So let me see. I'm going to wait here for a moment and pull up the participants window and see if you were not able to do it. Can you raise your hand so I can help you? The goal is for you to be able to see this file in your own Colab. Okay, so it looks like everybody got there and you're able
No, I
to.
didn't. I need help for some reason. I need to do the Google Colab, and I click the open with down arrow, and I have to search for it. And
Oh, right. So if you don't have Colab already, you have to say more tools and then find Google Colab that way. Mike, Robert, Anna, was it Anna just speaking? No. Okay. So who else has a
Yes.
question about
yes,
that?
it was me. Sorry, it just takes a while for me to click on this.
Hi, Chandru.
Yeah.
Yeah, so how do I get to Colab?
All right. You don't need to get to Colab. What you need to do is double click on this file. So you've made a copy of it, right? So you have a file that says copy of P4A Kepler activity.
No,
Have you done
I
that?
don't have that. I didn't do the copy. Oh, yeah. So I just do a make a copy, right?
Yeah.
Of
And
the
then
entire
you go to
presentation.
My Drive, and then that it'll show up there.
Okay.
Andra, as we spoke earlier, I with the Google Drive account that I'm using, which apparently the email address is a problem. You haven't in shared with me, there are no files of from this.
Yeah,
program
so
for
we'll
this
have to
study.
solve that
So we
problem
need to
later.
solve that offline.
Yeah, we can. Yeah. Okay. So one thing you can do to make sure that you're logging in correctly, you can say, you can just right click and you can say open Google Colab. If you don't see this, you can say connect more apps. I think that was one of the questions I had. And then in here, you can type in Colab. Oops. And then you should see Collaboratory, and you can click on that. So you could do that if you were not successful getting it to open with Colab. So then all you have to do is right click, open with Colab, or double click. Either one should bring you here. So let me ask that question again. is everybody able to see this document? This is a key step for us to proceed.
Is this the Kepler activity?
This is the Kepler activity. Yeah.
Okay.
And up here, good. So if anyone is not able to do that, I'll be glad to help you. Just let me know if you cannot see this document. So this document now is owned by you. So the first thing I want you to do is, instead of copy of, go ahead and click there and you're able to see my screen. So just put in your initials like that. So CN copy of the Kepler activity. So put in your own initials so that you can, from the file name, it's yours. Okay. So once you do that, one of the
Chandru, I
things
still can't, Chandru, I can't do it. It just doesn't work for me.
Oh, okay. Did you go to, the key is you need to go to My Drive,
Yeah,
and then do it from there.
that's what I was doing it from. And all it does is ask me to download. And I
No,
can't,
if you right click and say open with,
let me try it again. Yeah, I don't have Colab. I tried to download Colab and it doesn't
okay,
seem.
all you don't need to download Colab, just say connect more apps, just like that.
Yeah,
Pat.
yeah,
Connect more apps, and then look for Colab,
right.
and then click on, when you see the Collaboratory, click on that.
I did, and it says now it's asking me to uninstall it.
Oh, so that means you have it.
I have it, yeah.
Okay, if you have it, then do this, Pat. Then all you have to do is double click on that file and
Yeah.
then tell me what you see.
You're saying left or left click?
No, this time just double click.
Yeah. Let me get back to it.
And you can share your screen if you want, because others may benefit from this.
Yeah, let me double click it. Okay, I'll share my screen because it's just not working. Let me see. I'm sorry to take the time.
No problem.
Share my screen.
Just go ahead and share your screen.
Okay. Share. So when I double click it, this is what I got. And when I say connect.
Okay, no, don't do anything. Don't do anything. Don't do anything. Just go up and it says open with the notepad. Click that and then say connect more apps.
Yeah, and when
then type in Colab in the search apps. Yeah.
Let's see, it says uninstall. It's
yeah, and if you uninstall it, you can install it again, I suppose.
okay.
Okay, install, continue. Okay, now choose your account that you logged in with your student. Okay, so now go ahead and select again from the top where it says open. Okay, you'll have to refresh your window and I think you'll see it, if I'm not mistaken. I may be wrong.
Okay.
And then go to your My Drive and then copy of Kepler activity. I see that down there.
Yeah, okay.
Double click that. There we go.
Oh, okay. Now it's working. Okay.
Yep.
Good. Thank you.
All right.
Sorry.
No problem. So yeah, go ahead and stop your sharing. Anybody else are having trouble getting this far? Good. So let me share. Hold on. Okay. So I'm going to share my desktop again. All right. And this is where we were with our activity. Okay, CN copy. So far, so good, everybody? All right. Now, what I want you to note here is as we look through this. Now, this is your own copy. You're going to modify this. So this is a dynamic digital document. So by that, I mean, you see the table of contents here. If you click on this, you'll see the table of contents. If you click on this, it goes away. And you see a cell here. This is called a code cell. So what you can do with this one is if you double click on this code cell, you should see the code that it took to produce this text and image, and how the image is sort of floating around the text. And you can see how this text, this image was imported. And the first thing I want to show you is this statement right here. You see the double. You see the.
Can you show us how you open that up? I missed it. I looked
Okay,
away.
so just double click anywhere in the image. So double click, and then you should see the code.
Thank you.
Yep. Okay, good question. So then what you see here on the right is produced by this code. This is called markdown syntax. So this markdown syntax on the left here produces this nice looking piece of code. So what you see here is a HTML extract that downloads this image from this particular website. What we're going to do is we're going to learn how we can get these kinds of images to be shown on this website from our own Google Drive will be our next step. Okay, so Anna, do you still have a question?
No, that was good. Thank you.
Okay, you can put your hand down. So, all right, good.
How do you get out of this? Do you just
What's that?
Click again if you want to get out of this mode.
Oh, just double click again.
Okay.
So double click takes you into this editing mode, and then double click again will take you out.
Okay. Thank you.
Okay. So now what you see here is, if remember, there were two hash signs. Now that tells me that this is a header. So if I have 3 hash signs, right, you see it becomes smaller, right? And if you have 1 hash sign, it becomes bigger. So these are the headers, and this symbol here allows you to create a header. And then I have imported this image, and we're going to see how we can import this image from, instead of a website like this. This is coming from GitHub, by the way. We'll eventually do this, but it can also come from my drive, and we can figure out how to do that from your own drive. And then what I'm doing here is I'm saying the width is 300 pixels. I can say, oh, I want a bigger size, 500 pixels. You see how everything is now floating correctly, and you see how you can change pixel sizes and everything works. And that's really helpful when you're trying to create a nice looking document for somebody else to see, and all of this can be published. So I'm going to go back here. I'm going to make this 300 pixels again. This is called markdown syntax. And this is what is used throughout GitHub and throughout Colab. It is very useful to know. And you may ask me, oh, where can I learn more about the markdown syntax? Well, that's what these different this helpful links file will allow you to do that. Now, the helpful links file itself is another Colab. So go ahead and click on that and open it on your system. And you see, this is another Colab file that I wrote that has a bunch of links that is useful for us. It's got links about Python, about drawing scatter plots, and a variety of other things. And it also has links that tell you a little bit about the Markdown editor and what are some good examples. So not only can you create instructional documents, but you can create documents that contain code. So that's the last thing that I want to do today is write a small piece of code. Let's go back to your Kepler activity. So I'm going to cover how I did these equations later on. I'm not going to do that right now. You see how we say p squared is proportional to a cubed. This is by the way, this is Kepler's third law that says that the square of the orbital period is proportional to the semi-major axis of the orbit. So you can create these equations by using something called LaTeX. This is LaTeX language. So we will learn a little bit, but the beauty of this is this file belongs to you now, and you can simply reverse engineer how this is done. You can play with this. You can look at the links. This is available to you for you to create your own fancy documents. Here are some more equations. You can create some pretty complex equations with this, and they look good. You know, no more fiddling around with copying and pasting graphic documents into your document. Okay, so now let's see how we can write some code. So go ahead and click on this, and you see up here, if you move your mouse just to the top, you will see two fields like this. One's called code, the other one is called text. This is a text cell. We're going to create a code cell right above this text cell. I'm going to click on that. And here is a piece of code that I'm going to write. I'm simply going to say here, I'm going to say distance to sun, and that's a name of a variable, and I'm going to give it a value. What do you think I should give a value here? What is the distance to our sun?
100,000 kilometers.
It's a bit more than that. It's actually in millions of kilometers. Anybody else want to take a guess?
146
million.
Yeah, 150 million, right? So how do you write 150 million in exponential notation? 150 E6. So E stands for 10 to the power of 6. This is how you specify 150 million. So that's, and then I want to write comments. I say / here and say kilometers. Okay. So that's 150 million kilometers. And then let's go ahead and say, I want to convert this into miles. And so I want to say distance to sun in miles equals, then I'm going to give it this value, distance to sun, that's in kilometers. So what do I need to multiply this by to convert kilometers to miles? Does anyone know?
0.6-ish.
Yeah, 8 miles is 5, 8 kilometers is 5 miles. Therefore, I can go and say 5 over 8. Okay, so then I can simply print distance to sun in miles. Okay, now I've got some Python code. By the way, you don't need this semicolon. I'm a Java programmer, so I tend to think about Java, and I do this and then click this play button. So now what Google is doing, okay, sorry. So print within parentheses, and it told me what the error was. So I'm going to run it again. And of course, I'm using Java style comments. So these are no good. Okay. And here we go. So it actually gave you an answer, right? So this is 93 times 10 to the 6, right? So 93 million miles, and that's correct. So the idea is that here is a document, and you can write a piece of code, and you can execute that piece of code. This is Python. You can execute that piece of code, and it gives you some answers. So that's all we will have time for today, but I just want to show you how you can have text cells and code cells, and then you can have this code, you can run this code. So you may ask the question, where is this code running, right? You're in a browser. You don't have Python on your system. You could be on a Chromebook for all you know, right? So you have not installed a compiler. Where is this running? Well, what happens is that Colab allows you to borrow a GPU from Google. And so this piece of code runs on that GPU and produces the results. So the idea is there's no installation here. You haven't installed any compilers. The same, we'll start to plot this data. We will start to do queries like this and all kinds of, cool stuff we can do. So I'll stop here and ask if any of you have any questions about how we did this. Can I answer any questions? Can I help you with that? I just want you to at least get to this point before we wrap up today.
So Chandru, all we have to do is, once you go to the Colab for the, the first page, right? The Kepler's first law. I mean, third law.
Yeah. Let me share.
So in there, you just add the code, right?
Yeah. You
Okay.
basically go to your text block, and then if you move your mouse, it's sort of hard to see. If you move your mouse, do you see the code and text appearing?
Yeah.
So if you press the code here, it's going to give you another code cell. If you press text here, it's going to give you a text cell. This is an example of a text cell. This is an example of a code cell, and this is the output from that. So those are the steps.
There's also a code and text on the top, right? The beginning.
Yes, you could do it here too. You can click the code here and gives you another code.
Okay.
Yeah.
So where do we put the units? Like, you mentioned distance to sun.
Right. So you can just put comments here, right? You can write a comment, and the comment in this case is a pound sign instead of double slashes. Yeah.
Okay, thanks.
Yep. And we will be able to print text and numbers and all that. I don't want to get into all that because that's just Python syntax, and we will cover all of that in our next session. So let me see. Let me go back to the participants. I know some of you are new to Python and to Google Colab. So have you been able to get this far? Can I get some yeses and nos from some of my high school students to make sure? Okay, I see some yeses. You can give me a thumbs down, and that's perfectly okay, because then that'll let me know that I can help you. Cool. Looks like everybody is following so far. So one thing you can do is, since you own this document, I urge you to play with it, modify it, and see what happens. If you screw it up, no big deal. Simply go back to your Google Drive, and then you can delete it, right? Because I said here CN copy, right? No big deal. I can just simply trash it. And I don't have to worry about it because I can always get it by going to shared with me and right click on the P4A Kepler activity and then simply say, make a copy. Boom. And then if I go to my drive, I have another copy to play with right there. I can double click on that. So you don't have to worry about losing anything, but I would highly urge you to look at how these equations were entered. I can double click to go back, and you can learn a little bit about Colab. You can start to look at how this Kepler space activity is designed. And we will be doing a lot of stuff here as we go through. And Ram, you asked about units. You can see how we are printing information with units here. So we will be doing a lot more of this as we go, and we will be making plots and whatnot.
Chandru, can you add code blocks any place in a text block, or does it go below the text blocks, or how does that work?
Yeah, the code block is separate from the text block. You can do some things in the text block itself, which is pretty fancy, like write these equations and so on. But you see, here is a text block and here is a code block. They are always distinct.
So that you can't put a code block in the middle of a text block.
No, but you can split up the text block into two pieces, right? So then basically you can go here and then say, oh, I want to add another text block. So for instance, you see how if I move here, I get the code block, right? And text block. Let's say I add a code block here, right? Not a code block. Let's say that I'm going to delete that. Let's say I want to add a text block here, but I want this thing to be in the middle of the two text blocks. All you have to do, you see this little arrow, you click that. So now you've got a text block here and another text block here. So I'm just going to say here, another text block.
And can you copy and paste from one text block to another?
Absolutely. And you can click this and, there's all kinds of things that you can do.
Okay.
So now you've got this particular code block embedded in between two text blocks that you see.
Chandru, I noticed you have spaces in your equations between on both sides of the equal sign, and I'm just having problems with spaces. Is that not?
Yes, and you see how basically this is the LaTeX syntax I use to generate this, right? And so you see how I've got D subscript AU equals 1.5, 10 to the 11, right?
Right.
So you see right here, I've got the okay, so now because this whole thing is in a text block, it works this way. Are you saying that you're not able to get this padding? Is that what you're saying?
No, in the example you were doing with this with the AU calculation at the top, I noticed that you were putting spaces in there around the equal sign when you wrote your equations.
Oh, right.
Code, and I just wanted to be sure that that's acceptable.
Oh yeah, yeah.
Oh,
I
yeah.
mean, this is not code, right? This is in the text.
No,
block.
no, I'm not talking about the text. I'm talking about when you were entering the equation. For example, that distance to sun equals.
Oh, you mean in Python code?
In the
code
okay. Block, you had spaces.
Yeah.
And
that's just for readability. That's all.
Yeah. Okay, so it's not finicky about having spaces.
No, Python doesn't care about spaces or tabs. Yeah.
Okay.
The only thing is you cannot put a space or a tab in a variable name. So that you cannot do. So in the code that I wrote, I don't know if I have it anymore. I don't think I do. But I basically, you cannot say distance to sun. That won't work.
Right.
This is, you'll have to have either underscore or dash or something.
Okay.
But I can put as many spaces here as I want, and it doesn't matter.
Okay.
Yeah.
That's good to know.
Yeah.
Thank you.
Hey,
yeah, and we will learn a lot more about Python as we go through. And so we'll learn the syntax of Python. Today, all I wanted to do was to really talk about how to build a Colab file and how to create text blocks and how to create code blocks. And that was all I wanted to do today. All right. So any other questions from anybody I can address?
Yeah, hi Chandru, can you hear me? Yeah. So I accidentally deleted the first content from the table of contents, like the Kepler, who is Kepler, and his third. How do I get it back?
Oh, I would say at this point, you should go ahead and go to your My Drive,
And delete and make a new
delete,
copy?
delete the copy of, right? Simply remove it, and then go to shared with me and get it again.
Okay,
Make a copy and then boom, because that is a fairly complex text cell. For you to create it, it'll be too hard to do it from scratch.
okay,
And then once you have it, go at it, right? You can copy it, you can duplicate a text cell, so you can do whatever you want.
okay, thank you.
Yeah. Robert, did you have a question? You have your hands up?
Yeah, I was wondering, you put kilometers at distance to the sun, and you leave a space, and then you make two forward slashes, and then put km. Is it?
Yes, that was my fault because I was using Java style comments. So
Not correct.
yeah, so that was really
Okay.
intended to be a comment.
Okay.
Yeah.
Thank you.
And I think the Python comment symbol is a pound sign.
Okay. Thank
We
you.
can test that here. Let me go. Are there any questions I can address as we wrap up this session? So let's see. I don't see any other hands up. Speak up if you have any more questions. All right. So to address the question from Robert, let's go to this copy off. Let's just add a text, a code cell up here. And my test equals 5. And then if I say pound sign, this is a comment. Okay. And then I'm going to say result equals my test star 5 print.
Does this work with Control C? Copying?
And then I run it and it should work. Yeah. So pound sign is the comment for Python. I'm sorry. What was it, Robert?
You use Control C to copy.
Oh yeah. You can select here and Control C and or if it's Apple, Command C, either one.
Okay.
And then you can paste like that.
Oh.
Can you
So
right
you
click?
can use Control C and Control V.
Yeah.
If you're on a
Control C, Control V, or Command C and Command V if you're using a Mac.
Okay. Thank
How
you.
about
And
right
there
click?
are,
Does
you
that-
can also do things here. You can copy the whole cell, right? And then you can paste it.
Okay. And so, and there's a different way of adding units on the end. You can't, can you just put a KM after the 5, or is that not?
So we will, yeah, so you'll have to use a different print statement to be able to get the units, and we will cover all that. That's
Okay.
Python syntax, and we will cover lots of good stuff like that. Yeah.
Okay. Thank
But
you.
for now, I just want to show you how to comment code. That's all.
Okay.
Yeah. Any other questions? All right. So should we wrap up for today? Yeah. Okay. So thank you for joining today. If you have any questions, please message me on Slack, and I'll be glad to answer your questions. And I will see you next Thursday. I'll hang
Great.
out for another 5 or 10 minutes for those of you who want to ask me things that you didn't want to bring up during class.
Thank you.
You're welcome.
Good meeting,
Bye.
Chandru.
What's that?
Bye, thank you.
You're welcome. Thank you.
Thank you. See you next week.
Oh, see you next week. Thank you very much. Renisha, were you able to get the things that we did today?
Yes, I was able to get it.
All right, awesome.
Yes.
Glad
All right,
to hear
thank
it.
you.
Yep.
Chandru, will there be an assignment for next week? Is that going to be in the classroom?
The assignment was for people to just play around with the document that they created. I just wanted them to look at. I'll remind them of that.
Oh, okay.
Basically to play around with the syntax to create equations and things like that. So there is enough here for them to play around with. I didn't want to start out too heavy here.
Yeah, no, it's fine.
Yeah.
Okay, didn't know if I'd missed it. Okay. This is good. I I learned a lot.
Well, that's good. I wasn't sure if I'm being too basic about this. I wanted to make sure that I was being slow and deliberate, especially because there are a lot of high school students here.
Well, trust me, the old students are more are more handicapped than the high school students.
Oh, okay. Well, that's probably true. Yeah.
You're getting a lot of questions from us old people.
Oh, no, that's great. I mean, sometimes the children don't want to speak up. So.
Well, that may be true too. Yeah.
Yeah.
Yeah. But no, this was nicely done.
Oh, thank you very much. One thing I did want to say is this is a seminar and, none of these things are going to look like super pretty. It's going to be sort of cobbled together in a lot of ways. And I don't want people to think that this is going to be, like Grady's work is always so perfect, and I'm sure he spent hours and hours on that. But I wanted this to be a very hands-on thing. And so,
no, and this is perfect. I mean, it's exactly the way it should be done. And to be able to have it, I never really understood how you could bring it to my desktop or my Google Drive to be able to play with, and how I could experiment with it, but not worry about what I did to it.
Right. And so where we're going next, Pat, so for instance, let me share my screen again. So where we're going next is, these images now can come from your drive, right? Because right now, this image is coming from my GitHub. Instead, this will come from everybody's own GitHub.
Oh.
Right? Because then the idea is they can produce a digital document like this, right? For anything. It's not just for astronomy, right?
Yeah.
They can use it for any of their classes. And so that's the goal.
Okay.
Is that, this is not just for astronomy. The GitHub and Markdown syntax and Google Colab are universal tools that students can use. So that was one of my goals in this class.
Yeah, is GitHub off? Is it provided by Google?
Yes. So at next session, we're actually going to create a GitHub account.
Okay.
So
we
we haven't done that yet.
GitHub account. Okay.
Yeah.
Okay.
Yeah. And each student will create their own. Yeah.
Okay.
Now, this may be a little slow for some of the people here, but hopefully they get a sense for what this is about. I didn't want to lose my main focus is my students, high school students and college students. And so I didn't want to lose them. So
no, I agree. But trust me, the people I know who are the older people, not students.
Okay.
This is all new information. Trust me.
Oh, great.
Oh yeah.
As long as they won't be bored.
No.
Yeah, I think the real fun is going to happen when we start to query data and actually get stuff back from Gaia and from and then we start to do scatter plots and things like that. But
that's going to be hugely fun.
Yeah.
I'm just I can't wait because I can see so many things that we could do in terms of targeting.
Yeah.
Or observations.
Yeah.
That would be really enhanced by by having these tools.
Yeah, so I think, for instance, to be able to query for just the, let's say we target the Hyades cluster, right? So
Mhm.
just to be able to target that cluster and get, the 300, 500 stars from there and not from anywhere else in the sky, that will be cool,
Yeah.
right? Because then we can use those stars to plot the HRD, and it'll look very different when we do the same for the Pleiades cluster,
Right.
because one of them is much younger than the other. So
That's cool. That's very cool. I've got a little bit of a thing in the back of my mind. We're doing a lot of speckle interferometry on
yeah,
close binaries, and there's a all of a sudden I have a senior moment of forgetting the name of it, but anyway, there's a parallel to the main sequence when you get into the red dwarfs.
yes,
That's
yes.
above the main.
Slightly above, right.
Yeah, you know what I'm talking about.
Uh-huh.
Yeah.
Yeah.
And that one, we've got sort of an observation program going on, but there's also something going on over on the white dwarfs.
Oh, right. On
And
the
I
bottom
really
left
want to
of the
drill into
HRD.
that.
Yeah.
I really want to go drill down into that.
Oh,
Select
sure. Yeah,
and
we will
find some targets.
do an overall HRD for 1 million stars also as part of this exercise.
Good.
And you will see white dwarfs come up on the bottom left.
Yep.
And then you'll see the red giants on the top
Yep.
right. And then you'll see all the, the red dwarfs and, the really small stars.
Yeah.
Which is the majority of the galaxy, right?
Can we, can we do it? Would I be able to do it? Not that we have to do it in class. Would I be able to do a search on either apparent magnitudes or only select those stars in the
Absolutely.
Gaia?
You can, I mean, there are probably 50 things you can filter on.
Okay.
You can filter on absolute magnitude, apparent magnitude. You can filter on, you can say this distance or this parallax.
Right.
You can say right ascension, declination. You can say temperature.
Yeah.
Radial velocity. I mean, you can filter on just about anything.
Super. Super.
That'll be kind of fun.
That'll be, I can't wait.
Yeah.
It's very cool.
Yeah.
I'm loving this class.
Yeah. So we'll slowly develop the tools and then we'll sort of put it all together, hopefully by the third week. And then after that, it's just playtime,
Uh-huh.
Yeah.
Okay. Excellent.
All right.
Really good. Well, have a good night. Thank you very much.
You too. Thank you. Bye, Pat.
Bye.